Thank you, Ian. I'm Bill Wells. I'm coordinator for this class. And David Karowe is a professor of biological sciences at Western Michigan University. Here, he received a BS in biology from Harvard University and a PhD in ecology and evolutionary biology from the University of Michigan. He has received numerous federal grants in support of climate change research and training, and he has published many scientific papers and presented numerous climate talks. In fact, he did present to HASS back in October of 2019. The title of that presentation was Two Possible Climate Futures for the Great Lakes Region. And he outlined in quite a bit of detail the difference between business as usual versus the Paris Agreement. And it was kind of scary what he was presenting to us. He also presented a significant amount of evidence confirming that the warming we are experiencing is in fact from human activity and not natural causes. He will do his presentation, and at the end of the presentation, then you can either enter your questions. You can enter your questions anytime into the chat area, and then if you'd like to speak in person, we'll do that after his presentation. So without further ado, here is Dr. David Karowe.
Thank you, Bill. Can you hear me okay?
Yes.
Okay. And thank you, Ian, also. It's always a pleasure to participate in HASS. And today, yes, the topic will be basically if we were to decide to reduce greenhouse gas emissions, what would be the benefit in our own backyard? What would be the benefit to the Great Lakes region? There would be huge benefits globally, but we're going to focus on our little part of the world here. And what I'll do today is address three main questions. The first is, as Bill had mentioned, how do we know that climate change is happening because of us and not because of this sort of vague thing called natural factors, which turns out to be sun and volcanoes? But how do we know it's us? Second is, what's been happening in the Great Lakes region? How has climate been changing where we are? And also, how have species been responding? Do we have any evidence that they're noticing that climate is changing? And then the bulk of the talk will be about the future. How will future climate change that would result from one or a different emission scenario? So how will the emission scenario affect future climate change, and what will that do? How will that alter the impact of climate change on species and ecosystems in our region? And as Bill suggested, the easiest comparison, or the one that has been modeled the most, is continuing along our current path of heavy reliance on fossil fuels and very high greenhouse gas emissions, which generally is referred to as the business as usual future. And the other that's been modeled quite a bit is the Paris Agreement future. But the Paris Agreement future, in its sort of basic form, results in about half the amount of warming that the business as usual future does. We'll talk also about part of the Paris Agreement, which was sort of we can do even better than limiting warming to 2 degrees. We're going to try to limit warming to 1.5 degrees. And there are some predictions about how 1.5 degree warming future would affect our region. We'll talk about them when we can. Okay, so first thing, I always like to start with a pretty striking visual. It's a video, 30 seconds long or so. You see the URL at the bottom. It's put together by NASA's Goddard Institute for Space Studies, and this is a color-coded depiction of thermometer readings across the entire planet, averaged over a 5-year period. You see it at the bottom. And the comparison here is the temperature of that place, wherever it is, let's say Brazil during that 5-year period relative to the same place, Brazil, during the reference period, which is 1950 to 1980. Okay. So for instance, on average 1880 to 84, most of the world is blue. Most of the world was cooler than it was on average during this 30-year period. We'll just see how that changes over time. You can see that the numbers, the dates are going by pretty fast. So it's undeniable that temperature has been rising on our planet. I don't think anybody claims now that climate change is not happening, but there is the question of what's responsible for it. One thing that says it's not natural factors is the fact that current climate change is way faster than any that we have a record of. And from the ice cores in Antarctica, we have about 800,000 years of temperature record, and it is visible in the ratio of oxygen isotopes in the ice. Not something that we need to talk about, but it's a pretty good record of almost annual changes in temperature. And over the last 800,000 years, Earth has never warmed this fast. In fact, this is about an order of magnitude faster than the fastest in the ice core record. So that the fact that it's a qualitatively different type of warming tells us it's probably not due to the same things that caused the past warming. Let's address it directly. How do we know that climate change is not caused by natural factors? Well, if we look at the ice core data and the temperature record preserved in the oxygen isotopes in the ice core data, what we see is from 1 million years ago to today, climate cycles. Earth has clearly been undergoing about 100,000 year long climate cycles. And we know why this happened. We know why every one of these warming periods in the last million years, we know why they've happened. They've all happened because we've been getting more energy from the sun during those times. Our position in space relative to the sun changes, and sometimes we're closer, sometimes we're farther, sometimes we're tilted more towards the sun, sometimes less. All of those are cyclic changes in Earth's position relative to the sun that influence how much solar radiation is striking our planet. That's where our climate heat comes from. So those have been changing in a cyclical fashion, and that has caused climate cycles on the planet. So that's all due to changes in solar input, and the warming is always increase in solar input. So the first thing we would want to ask is, okay, so have we been getting more energy from the sun during this current warming period? And it turns out that while the Earth has been warming the fastest the last 70 years or so, we've actually been getting less energy from the sun. So if you look at the change in temperature, very strong increase, and the change in solar irradiance, a mild decrease, it's very clear that what caused the warming events in the past, the warming part of those climate cycles, is not causing the current warming. And without going into any great detail, I would argue that since the only natural factor that can cause Earth to warm is actually changing in a direction that would cause Earth to cool, natural factors can't explain any of the current warming. And consequently, I would argue that 100% of current warming is due to human activities. Two main things we're doing that are changing the atmosphere, composition of the atmosphere. One is burning fossil fuels, which is basically organic material, carbon heavy material that has been buried underground for maybe 350 million years. And we figured out how to burn it and make the energy that's released do work for us. So we've been burning fossil fuels as soon as we figured out how handy they were, without knowing that we were going to be changing the atmosphere as a consequence. That's about 80% of our influence. About 20% is through what's generally called land use change. And that is primarily deforestation. So when we cut down a forest, and especially tropical forests, rainforests, for agriculture or well, really for any reason, but normally it's for agriculture, and a lot of that agriculture is cattle. When we cut down the rainforest, the carbon that was in those enormous trees has to go somewhere. And most of it goes right into the atmosphere because it either burns or decomposes fairly quickly. A little bit of it is put into housing and so on, but the vast majority of that carbon goes into the atmosphere, and there is no longer a tropical forest to pull carbon out of the atmosphere. So that's about 20% of our overall influence. Okay, so there really isn't any reasonable argument that I think any of the current climate change is due to anything but humans. And in fact, there hasn't been a legitimate scientific society on the face of the earth, in any country, anywhere, for more than 10 years. There hasn't been any legitimate scientific society that states that climate change is primarily due to anything other than humans. So even the petroleum industry recognizes that. Okay, so let's ask how climate's been changing in our part of the world. The first thing we can look at is temperature. Temperature in our part of the world has been behaving pretty much like the global average, and that is it's been increasing, and the increase has actually been the rate of increase has actually increased fairly dramatically. We're warming a lot faster than we used to be. Since 1975, the rate of warming in our part of the world is 4 times what it was over the entire thermometer period. And the total amount of warming is about 1 degree Celsius, so not quite 2 degrees Fahrenheit. But that's enough for species and ecosystems to respond. Okay, because it's been warming, because the air has been warming, of course, the land and anything on the surface of the Great Lakes region has been warming too, including the surfaces of our Great Lakes. And the water of the Great Lakes, especially the surface water, has also been warming. What you see here is in color any place in any one of the Great Lakes that's shown statistically significant warming since, well, actually from 1994 to 2013. So basically a 20-year period. There are parts of Lake Superior that have been warming at, let's say, 0.3 degrees C per year. Over 20 years, that's 6 degrees C. That's an enormous change in the temperature of the surface water. And it is that heating is penetrating to deeper waters, detectable in Lake Superior to about 200 feet depth. Okay, and we see that parts of Lake Michigan have also been warming fairly rapidly. If you have warmer water, the ice is not going to be covering that water as much of the year. So as a consequence of warming water, ice cover has decreased and quite substantially by about little over 70% over the time period when, sorry, I'm just going to see if I can move the boxes for entering, people entering and so on have been covering up some of my text. So maybe not for you, but I think I've corrected it for me. Okay, so since 1973, huge loss of ice cover pretty much everywhere in the Great Lakes. Again, any colored area has seen a significant decrease in ice cover. It's very detectable by satellite. The other big part of climate, besides temperature, is precipitation. And precipitation is much more variable over space and time than temperature is. And it's harder to measure and harder to detect changes. But even so, it's clear that precipitation, average annual precipitation, has been increasing for most of our region. And it's been increasing by somewhere between 5 and 15%. Unfortunately, little to none of that increase has been in the summer. Most of it has been in winter and spring. And a big part of that increase is in what are referred to as extreme precipitation events that over the last century comprise 5% or less of the precipitation events. So these are unusually strong rainfalls, the kind that basically bring human activity, at least outdoor activity, to a halt. And our part of the country has experienced the biggest increase in severe precipitation events, extreme precipitation events, only behind the Northeast. So we've had about a 40% increase since 1958 in these extreme precipitation events. As a consequence, there's been a lot of flooding in our region. That's Ann Arbor, Grand Rapids, Kalamazoo, East Lansing, of course. And the flooding in our region has clearly become more frequent because the severe precipitation events have. Kalamazoo in the last 10 years has had 3 once in a century rainfall events. I don't know what it's been like in Holland, but I suspect same kind of increase. Okay, so we've got really noticeable changes in at least 2 main components of climate, temperature and precipitation. So we can ask, well, have the species in the ecosystems in our region been responding to that at all? And there are several kinds of responses that have been noted, not just in our region, but throughout the world. One is that plants do whatever they do in the spring a little bit earlier. They are putting out their new leaves. If they're deciduous plants, they're putting out their new leaves. Or if they're spring wildflowers, they're putting out their flowers earlier. And the advancement to doing things earlier in the spring is pretty well documented across most of the United States, except for the Southeast. But in our region, most of the spring events that plants and animals do are happening 4 to 12 days earlier since 1950. One of the spring events is the arrival of migrating species, the return to their summer breeding grounds. And it turns out that on average, migratory birds in the Great Plains area, probably also in the Great Lakes region, although we don't have the data to confirm it, are arriving on average 4.5 days earlier than they used to. Remember that spring is advancing, at least in terms of what plants are doing, 4 to 12 days earlier. So birds are arriving on average 4.5 days earlier. Each circle in this figure is a species, a bird species, and a bird species that is arriving at the same date as it did on average 1910 to 1940. If it's now arriving at the same date, then that species would be right on this line. It hasn't changed its arrival date. Of course, you can see that when we look at those arriving later and those arriving earlier, there are many more species that are arriving earlier than they used to. But that doesn't mean that they're keeping pace with the changing climate, because it's not just that you need to arrive earlier, you need to arrive as much earlier as you need to advance your arrival date the same number of days as spring is advancing. So 4 to 12 days. 4.5 days doesn't allow most birds to keep pace with a changing climate. And it turns out that most long distance migrants, so ones that go down to Central America, South America, and a fair number of medium distance migrants, let's say Southern US, Mexico, are not arriving back earlier enough. So they aren't keeping pace with climate change. Wood thrush is a medium distance migrant, purple martin, long distance migrant, and they are not in this blue area, which is arriving earlier enough to keep pace with the earlier spring. They're in these groups who are arriving earlier, but not enough earlier. And that lack of synchrony with other things that are happening in Michigan in the spring will probably be very challenging for them eventually, if it's not already. If we look at trees and ask how they've been responding, well, partly the leaf out data from a couple slides ago says how trees have been responding as well, but they can respond in a couple ways. One is changing the timing of these spring events like leaf flush, but also by moving. Trees don't move very fast, but they do have seeds that can disperse. And it turns out that in the eastern US, just about a third of tree species have significantly shifted their ranges northward in 30 years. And this is a bit of a complicated figure. What you want to do is pay attention to the green arrows. A green arrow, each arrow is a species of tree. The green arrows are tree species that have shown a significant northward shift. They may also have shown a significant westward or significant eastward shift, but at least part of their change in geographic range has been in the direction that would be a good response to climate change. And it turns out that the range shifts have been in the right direction more for conifer species than for deciduous species. For some reason, conifers tend to be, so far, tracking climate change by moving north better than our deciduous trees. And of course, if 35% are moving north, that means that 65% are not. So 65% of our species have not shifted northward. These are all species that have not shifted significantly northward. The first 4 of these have actually shifted significantly westward. And trees in east of the US, about twice as many species have shown significant westward shifts than significant northward shifts. And 35% significantly north, 22% significantly south. So it's the trees in our region, or at least east of the Mississippi, seem to be a bit confused about where to go. And those that are shifting northward significantly are not, with only one exception, are not shifting north fast enough to keep pace with a moving climate. And that's a typical observation, that if you are shifting the timing of events or your position on the planet, whether it's a latitudinal shift or an altitudinal shift, even if you're shifting in the right direction, you aren't doing it fast enough. Okay, so that's what's been happening already. What does the future look like? And so if we ask, how will future climate change impact our species and our ecosystems? The answer is, of course, it depends on which emissions trajectory we decide to follow, and not just us in the Great Lakes region, but humans globally, especially United States, China, India, and European Union, who account for the majority of emissions. But the bottom line is that the future isn't set. It depends on our choices. And we know that In December of 2015, 195 countries signed on to the Paris Agreement, and it basically said we'll do what it takes to limit warming to 2 degrees Celsius above pre-industrial temperatures, and if possible, we'll limit it to 1.5 degrees. We may have to overshoot 1.5 degrees, but if we do, we'll figure out ways to bring temperature back down so that we end up only 1.5 degrees above pre-industrial temperatures. But the main focus has been on hitting this 2-degree target. And so what we'll talk about is how different the Great Lakes region would be if we were, as a species, to rein in greenhouse gas emissions and deforestation such that we would prevent Earth from warming more than 2 degrees. I think it's a good way to think about these 2 different futures is to compare them in terms of what levels of carbon dioxide the atmosphere would contain, and also under the different emission scenarios, and then also how those levels compare to historical CO2 levels in the atmosphere. So what we have here is carbon dioxide levels in the atmosphere in parts per million. The x-axis starts at 400,000 years ago, goes to today. This data also comes from ice cores from bubbles of air trapped in the ice at various times. And what's very clear is that carbon dioxide has gone up and down in concert with temperature. So the temperature cycles have been accompanied by carbon dioxide cycles, but for the last 400,000 years, actually 800,000 years, our atmosphere never got above 300 parts per million. It varied between about 180 and 280 parts per million CO2. 1950, we crossed the 300 parts per million level. We're currently at about 418 parts per million. So this current level, that's actually a little bit low, but of course this slide was made several years ago by the EPA. So what would the business as usual future involve in terms of atmospheric composition, carbon dioxide? It would mean that by the end of the century, our atmosphere would have about 950 parts per million. And as a consequence, Earth would warm by about 4.5 degrees above pre-industrial temperatures. Paris Agreement said, well, let's cut that down quite a bit. Paris Agreement says we will not let carbon dioxide in the atmosphere get above 550. That's still a lot higher than historical levels. And so it would cause warming, but not as much warming. It would cause about 2 degrees Celsius warming. And then a third one that, well, let's see if we can limit it to 1.5 degrees. I call the Paris Extended target. Nobody else calls it this, but it doesn't have a name. So I just call it the Paris Extended. It would be either not getting above 450 parts per million or getting above it, but then figuring out some way to pull carbon dioxide out of the atmosphere. And that would limit warming to 1.5 degrees. But mostly what we'll compare is these 2 emission scenarios, the ones that have been the focus of most of the modeling studies. But I do want to show how different our current trajectory would be compared to the Paris Extended, the 1.5 degree warming future, which technically is the RCP 2.6 emission scenario. Business as usual is the RCP 8.5, but we'll just think of this as the business as usual future and then the Paris Extended future. So we're heading towards a very unpleasant future. That's going to be the image on the right. But we can still change course. We can still make our future what will be the image on the left. And both of these will show changes in temperature throughout the century under these 2 different emission scenarios. Okay, so under the two different emission scenarios, this will be our Paris extended future, business as usual future. The year depicted in the globe at any point is right there in that black box. And we can start to see differences between these two emission scenarios within a decade from now. And the warming is always greatest at the high northern latitudes. But by mid-century, these are dramatically different futures. And that difference just increases as the century goes on. Warming basically stops in mid-century for the Paris extended future. Okay, so those are the two of the many futures that we have available to us, and which will actually come true depends on our emissions choices. Okay, this is a world where everything will be very difficult. Agriculture will be very difficult. Anything that requires water will be very difficult. Heat stresses for humans and other species also quite exacerbated. If we look within the Great Lakes region and ask, okay, if you focus your model on the Great Lakes region, what are the predictions for our backyard? Under business as usual, the prediction is GLR stands for Great Lakes region. That temperature would increase, BAU stands for business as usual. So under business as usual, temperature in the Great Lakes region increases by about 6.5 degrees Celsius or 12 degrees Fahrenheit. That's averaged over the entire year. Oh, sorry, that's the summer temperature. And so that's going to be higher. 12-degree higher temperature is going to be 12 degrees Fahrenheit, 6.5 Celsius. That's going to be a real challenge for Michigan agriculture for sure. Well, are we going to get more precipitation during the summer that would help to ameliorate some of the ill effects of increasing temperature? And the answer is no. In fact, the opposite. The prediction is that under business as usual, summer precipitation decreases, so by about 10%. That's a horrible combination for pretty much any living thing in our region. Would it be any different under the Paris Agreement? Yeah, under the Paris Agreement, instead of 6.5 degrees, the average temperature rise in the summer is 3.5, or about 6 degrees Fahrenheit. Still challenging, but nowhere near as challenging as under business as usual. And summer precipitation would decrease only by about 5%. It's still not great, but at least it's less warming and less of a decrease in precipitation. I don't know if we would still be able to grow soybeans in Michigan or corn. I think it depends to some extent on what new strains we can create in the meantime. But obviously, a Paris Agreement future would be much less stressful for species, ecosystems, and of course for people in the Great Lakes region. It would have big consequence for deaths due to heat stroke, for instance. Okay, so that's a focus on Michigan and just looking at average summer temperatures. What would be the chance that in the future, a summer would be hotter than what is currently the record hot summer for our region? And by 2070, under business as usual, the prediction is that 90% or more of Michigan summers would be hotter than what right now is our record hot summer. This is the global prediction where under business as usual, most of the Great Lakes region is red, which is 90 to 100% of future summers hotter than the current record hot summer. Globally, the global mean is about 80%. Would it be any different under Paris Agreement? Yeah, it would be quite a bit different, quite a bit better. That under Paris Agreement, it could be as few as 10% of future summers would be hotter than what is currently our record hot summer. Of course, if you get higher temperatures and less precipitation, that is the recipe for drought. And predictions have been made for global drought under different levels of warming, not actually including the business as usual level of warming, only up to 3 degrees warming. But with 3 degrees warming, by end of century, the severity of droughts in our region, the frequency would go up, but so would the severity. And the change in drought severity for our region is basically in the orange and red, which is 3 to 5 times, a 3 to 500% increase, or 3 to 5 times more severe than historical droughts have been. Under Paris Agreement, it would be actually relatively little change in the severity of drought relative to what we've been experiencing so far. So the change in drought severity, there are blue areas in here, which are areas that are predicted to actually see a decrease in drought severity. So Paris Agreement, again, droughts are the most lethal kind of extreme weather event for life on Earth. There's a reason it took life 500 million years to get up on land, and that was it's really hard to avoid drying out and dying, and droughts still are the most lethal kind of extreme event for terrestrial life forms. Okay, so if we look at ecosystems in the Great Lakes region, the easiest ecosystems in which to predict climate winners and climate losers is aquatic ecosystems. It's in both still water, relatively still water, so lakes, and moving water, so rivers and streams are going to be impacted, but in slightly different ways. Okay, and in both of these aquatic habitats, the basic prediction is if you like warm water, you're going to be a climate winner. Warm water species will be climate winners, but if you require cold or even cool water, then you're very likely to be a climate loser. And we'll talk first about lakes. The species that live in lakes are going to be affected by warming. The water will warm, but I think the cool and cold water fish will be affected even more by something else that nobody's really talking about yet. The species that live in flowing water will be affected by increased temperature of stream and river water, but I think even more so by changes in the flow regime of the water in rivers and streams. We'll talk about both of them. It turns out that if we just ask, okay, who's going to be a climate winner or a climate loser? Among fish, we can identify quite readily those that will be very likely be climate winners because they like warm water. And actually, more of a lake will be suitable habitat for them as the warming penetrates down from the surface. So carp, bluegill, catfish, white perch are likely to be climate winners, so will smallmouth and largemouth bass. But the climate losers are the ones that certainly form the basis of our fishing tourist industry or even resident industry. The fish that probably people care most about, whitefish, all of the trouts, walleye, and all of the salmons that are in our Great Lakes. Why? Because they're cold water fish or cool water fish. Why are they particularly vulnerable? Why will they be the biggest climate losers among fish in our area? One reason, and I think the biggest reason, is that it has to do with what happens to oxygen in lake waters during the summer. And that is a consequence of the fact that lakes become temperate lakes, not tropical, not really Arctic lakes, but temperate lakes become what's called stratified during the summer. Okay, in the wintertime, the surface is ice covered. And so the surface and the water just below it is 0 degrees Celsius. The water in the depth is always about 4 degrees. In the spring, the ice leaves, sun warms up the surface, so it's now 4 degrees. the water there is 4 degrees. And that means that throughout the entire water column in the lake, it's the same temperature. If it's the same temperature, then the water is the same density. And wind blowing across the surface can set up eddies and vortices and so on that will carry oxygen down to the deeper waters. But that can only happen when the lake is the same temperature from top to bottom. After a week or two, the surface water has now warmed up, and that means it's less dense, and wind cannot push surface water into the depths. So whatever oxygen gets mixed into the deep waters during the spring turnover has to last until the time in the fall when the surface cools down enough that the lake is again the same temperature from top to bottom. Then oxygen can get mixed down into the depths. The summer period is called the stratification period, and it starts after the spring turnover and it lasts until the autumn turnover. Okay, ice cover, basically when ice cover leaves our lakes, that's when the spring turnover happens. So we know we've been losing ice cover on the Great Lakes, 71% less since 1973. If we look at ice cover in 2021, last year, okay, compare it to the blue line here, which is the average ice cover on Lake Michigan throughout the cold months. What we see is that the 2021 ice cover was for most of the ice season much less than normal. Okay, and what I would point out is that from the point of view of things like walleye or trout, what really matters most is that the spring turnover is happening in 2021, happened much earlier. Okay, so in May, historically, May was when the ice was gone and the spring turnover happened. But in 2021, and in a lot of our recent years, it's happening in early April. So that's a month longer. Even if the autumn turnover didn't change, that's a month longer that whatever oxygen the spring turnover brings to deep waters, that's a month longer that it has to last. And we can ask, well, what are the predictions under business as usual and the Paris Agreement for the lengthening of the summer stratification period? And the pretty much the only two studies that I know that have addressed it both indicate that under business as usual, that summer stratification period is going to be way longer. So for Lake Superior, the prediction is 89 days longer. Whatever oxygen gets mixed down, it's got to last 3 months longer than it used to. For Lake Ontario, 77 days, so 2.5 months, and for Michigan, Huron, and Erie, basically 2 months longer. Will deep water fish be able to survive that? Will oxygen last that long? I don't know, but I think it's quite unlikely. So I think that a consequence of the longer stratification period, the immensely longer one under business as usual, is that deep water fish will suffocate. They basically run out of oxygen. They can't come to shallower waters where there is oxygen because they can't tolerate those temperatures. So cold water fish in particular are likely to be major casualties. Under Paris Agreement, the summer stratification period would increase, but not as much. So instead of 89 days in Lake Superior, it would be extended by maybe 50 days. That may be too much as well, but at least they've got a better chance of surviving. And then 50 days in Lake Ontario and about half the extension in Michigan, Huron, and Erie. And that may well prevent large-scale fish kills in our Great Lakes due to suffocation. It's not just the Great Lakes that would experience a difference in an increase in summer stratification period. So would all the smaller inland lakes. If they're 30 feet or more deep. They'll stratify and have turnover. So under business as usual, the prediction is for inland lakes. This actually happens to be Douglas Lake, where it has spent lots of summers at the University of Michigan Biological Station. 35-day longer summer stratification. Under the Paris Agreement, that would decrease to 24 days longer, and under Paris Extended, only 15 days longer. This 1 degree difference between Paris Agreement, 2-degree warming, and Paris Extended 1 degree actually has a lot of benefits. Doesn't seem like half a degree would, but it does. And this is one of them. Inland lakes under Paris Extended, even under the Paris Extended, the 1.5 degree warming future, inland lakes are predicted to lose, just through warming, lose almost all commercial and sport fish. Here's the present composition of the fish community in inland lakes. This is actually in Wisconsin, and this is the average of 645 lakes in Wisconsin. The part of the fish community that we pay the most attention to are red and green, the commercial and sport fish and the just sport fish. So there is never a big part of the community that is just sport fish. Usually it's commercial and sport. But what happens, even under the Paris Extended Agreement, by 2070, the lake becomes almost entirely forage and bait fish. Not the kind that you would typically bring home and cook or sell in a market or put up on your wall. And then under business as usual, it's basically the same thing. There is a little bit under Paris Extended, a little bit of commercial and sport fish left in Wisconsin lakes, none under business as usual. There are other studies that are trying to predict again, climate winners and climate losers, but where the prediction is focused on 2 species, one cool cold water species, one warm water species. And among these studies, again, done mostly in Wisconsin, the prediction is that walleye will be replaced by largemouth bass in most of Wisconsin lakes. Okay, right now there aren't many lakes, Wisconsin lakes, that are walleye dominant lakes, but there are 184 of them. There are many more that are already dominated by largemouth bass, and then some that are not really dominated by either. So that's the current distribution of lake dominance today, where there are 184 walleye dominant lakes. And this is actually I only have predictions for one emission scenario. It's a scenario that's not quite as bad as business as usual, but pretty close. By mid-century, the lakes where you can go and be pretty sure you're going to be able to catch walleye drops from 184 to 25. That green line gets thinner, and by later in the century, it's decreased by over 90%. So walleye is clearly a climate loser in Wisconsin. Largemouth bass is clearly predicted to be a climate winner. But it will have major consequences. Climate warming will have major consequences for lake ecosystems. For river ecosystems, river and stream ecosystems, warming will be an issue, but I think a huge issue also will be changes in what we call the flow regime. The flow pattern will be more variable for streams and rivers throughout the Great Lakes region. There has been a fair amount of attention to trying to predict changes in high flow days, which are mostly in winter and spring. So when snow is melting, especially if you get a rain on top of snow melt, you can have a very high flow in your streams and rivers, at least for a short time. High flow days can be challenging. They can dislodge and move downstream invertebrates and maybe some of the fish and so on. But the real challenge is not high flow, it's low flow. But we can look at under business as usual, what's the predicted change in the number of high flow days per year, almost doubling, 86% more, and increasing by about half under the Paris Agreement. Okay, probably not good news for things that live in our rivers and streams. High flow days are generally somewhat damaging, but it's the low flow days that are lethal. Low flow days occur mostly in later summer, and the water can get very warm. If it's shallow, its dissolved oxygen content can go way down. This fosters harmful algal blooms, and fish can get trapped in parts of the river that are no longer connected to the main flow. What's the prediction under business as usual? About a 50% increase in the number of low flow days. Under Paris Agreement, only a 3% increase. And I think for things in our flowing water systems here in the Great Lakes region, that's the big benefit of the Paris Agreement. And if it's a low flow, it really doesn't matter if you're warm water or cold water fish. It matters some, but not a lot, because neither can deal with the decreased oxygen content that would come with low flow days. If we ask about our trees in the Great Lakes region, as we know more about the physiological requirements and the dispersal capabilities of trees, these predictions will be updated. But right now, the prediction under business as usual is that of the 20 most abundant tree species in our region, 13 of them are predicted to decline by at least 50%. So paper birch, bigtooth, and trembling aspen, balsam fir, the white cedar, white pine, and sugar maple. These two I think of as the most iconic Michigan trees, but that's just my personal opinion. Okay, so under business as usual, we see large decreases, especially in southern Michigan, for all of those. Under the Paris Agreement, not all of them would decrease by at least 50%. All of them would decrease less than under business as usual, and 2 of them no longer are predicted to decrease by 50%. And 4 of them are no longer, 2 of which are white pine and sugar maple. If we ask not about individual species, but ask about forest types, Great Lake forests are predicted to change pretty dramatically under business as usual and less dramatically under Paris Agreement. Here is the Forest Service's map of the current forest types in Michigan. And if you look at Michigan, for instance, we have 6 forest types. And if you look throughout the Great Lakes region, it's pretty much these 6 types. We have a little bit of white, red, and jack pine forest. That's where the Kirtland's warbler is. We have to our north some spruce fir forests. We have some oak hickory, southern Wisconsin, southern Michigan, a fair amount of elm ash cottonwood, a little bit of maple-dominated maple beech birch forest, and some aspen birch forest. So those are our current forest types. Not incredibly diverse, but at least 6 different types. Under business as usual, the prediction is that the Great Lakes region becomes almost entirely elm ash cottonwood and oak hickory, and in particular oak hickory. So oak and hickory are predicted to be massive climate winners if they can disperse fast enough. It's not clear that they will be able to. And also elm ash cottonwood. So we go from 6 forest types to 3. Under the Paris Agreement, it's not quite as bad a future. We go from 6 forest types to 5. And still elm ash cottonwood and oak hickory are climate winners, but we retain some of the jack pine. So Kirtland's warbler, for instance, would still have a place to live in Michigan. we ask, well, what effect would different emissions, certain scenarios have on birds in Michigan? Audubon Society has really good research on their website. If you Google Audubon climate and Audubon climate birds, you'll get to this website where you can look at the predicted fate of, I think it is 431 bird species. And you can actually look at the predicted fate for all of North America, for individual states, or even individual counties. This is the prediction for Ottawa County. In Ottawa County, they don't do business as usual. The highest warming is 3 degrees, but under 3 degrees, 16 species would become highly vulnerable. Here are 14 of them. Okay, so wood thrush would basically disappear. I don't know about you guys, but I really love the song of the thrushes, including wood thrush, the whippoorwill, piping plover that we've put in so much effort to save from extinction, would essentially be gone, or very, very close to being gone. So that's under 3 degrees. Under 2 degrees, instead of 16, it's only 5 species that are highly vulnerable. And it doesn't include, this maybe means more to me than most people, it doesn't include the wood thrush. That's no longer a highly vulnerable species. And under 1.5 degree warming, only 2 species in Ottawa County are predicted to be highly vulnerable. Okay, so birds in our region definitely are rooting for Paris Agreement to be implemented, and if possible, Paris extended. Okay, so we see that there are really very many benefits. We haven't even talked about benefits to human health, but benefits to ecosystem health of reducing emissions and thereby minimizing or decreasing the amount of climate change we'll experience. So how do we do that? What can we do to help minimize climate change? And fortunately, we don't have to invent anything new. We've got the technologies, we just need to implement them. So we can change the future, we can change course, not head towards the business as usual future by implementing any of a number of solutions that we already have available. And I'm sure you're familiar with a lot of these. I think the first thing we need to do is demand that the people who are making policy and controlling the trajectory towards our future, that those policymakers make policy that puts a very much greater emphasis on smart energy choices. So fortunately, our current president is aware of and concerned about the effects of climate change. And we did just get a fairly sizable, certainly the best climate change legislation the country's ever passed, in contrast to his predecessor, who set climate change mitigation back during his 4 years, really quite disastrous. So the people who are in power, and our governor, our 2 senators, our president, are all pretty good about supporting wind, solar, other essentially carbon-free energy sources. I'm not sure about Peter Meyer, but he's not going to be returning, I believe. So, but even they can do much better, and we need to do much better. What are our smarter energy choices? Well, solar and wind are remarkably capable of supplying energy to us. And what we need to do is get at least 80% of our energy from smarter sources like wind and solar by 2040. So make a lot of green electricity and convert everything we can that is currently running on fossil fuel energy to run on green electricity. So electrify the economy, transportation, and heating and cooling. What is the overall potential globally? Any one of 3 types of solar technologies could produce, with reasonable restrictions about where you can put it, any one of three solar technology, including the mirror focusing sunlight type, could produce at least 100 times all of the energy that humans use in all forms, not just the electricity, all of the energy that humans use. And wind is not far behind, especially if you include offshore wind projects. The global potential is 40 times electricity that would amount to 40, could power the world 40 times over. And it's, in my opinion, inexcusable to future generations that we are not shifting over to these. We're basically stealing our children's future by not implementing this solution, in my opinion. Okay, so talk to people who are currently making policy, and then make it a point to get people who would support the correct policies into office. So make climate change a major voting issue. It would be great if we could get all of the people who spend time, who work in these buildings and make legislation happen, to be as concerned about climate change as they should be. So our votes count. If we elected people who were willing to act on the science, we would have massive change in our trajectory, our future trajectory within 5 years. So I would encourage everybody to be a climate voter. In the meantime, until those changes happen, we can try to use less fossil fuel energy. 81% of the energy in the US comes from burning fossil fuels. So basically, if we practice energy efficiency and energy conservation, saves us money and does a little bit to save the planet around that. For household energy expenditures, the most influential thing that we can do is insulate. So weather stripping and so on. The second most influential thing is next time you buy a car, get a car that is either doesn't use any fossil fuel, so it's an electric car, or is very efficient in the way it uses fossil fuels. So the gas electric hybrids around town, you can probably run them entirely on electricity. I do on mine. But anyway, get a car that pay a lot of attention to the MPG of a car. We can switch our diets to a more low carbon diet. And that the biggest thing we can do is get beef, and to some extent lamb, but especially get beef out of our diet. Cattle are an enormous agricultural driver of greenhouse gas emissions, both carbon dioxide and methane directly. Methane mostly by burping, indirectly by being a reason for deforestation. So if you replace beef with chicken, that will be the single change that can do the most to decrease the carbon footprint of your diet. Of course, vegan has the lowest carbon footprint, vegetarian not far behind. Another thing we can do is not use so much fossil fuel energy to heat or cool our house. We can adjust the thermostat. I always say, turn it in the direction you really don't want to turn it in. So in the winter, turn it down, in the winter, turn it down, in the summer, turn it up. So we use less heating in the winter, less air conditioning in the summer. If you change the thermostat by a degree a week, almost nobody notices that. And then, of course, replace incandescence with fluorescence and replace fluorescence with LED lights. Okay. The problem with all these is they're great things to do. We should absolutely do them, but they don't change the outcome. They just delay it. What we have to do is not use fossil fuels, find substitutes so that we don't reach the same CO2 levels a decade or 2 decades later than we're currently headed towards. So that's why we need to implement the we need to massively scale up the green electricity technologies we have. And I think a big part of the solution is talking with others. Share this talk with others about the fact that we're causing climate change, what the consequences might be, and of course, what the solutions might be. And it does not have to be a long conversation. It can be something like, do you know that for over a decade, all the scientific societies on our planet have agreed that humans are the main cause of climate change? There's no dissent. Okay, you just plop that on somebody's plate, like a teller at the bank while you're signing the back of a check, and you're going. Sort of hit and run education about climate change, but put it on people's radar, and of course, have extended discussions if you can with friends. Those are going to be the easiest, maybe with people you work with. Again, doesn't have to be an argument, doesn't have to be a heated discussion. And especially with people who are not yet aware of the causes, the consequences, and the solutions. And I think especially with the next generation or next generations, especially with young people, and very important to get them to vote. They're much more knowledgeable than, the younger you are, the more knowledgeable you are about climate change, and the more scared you are. So last thing I'll suggest is get together with other people who share your concerns and your willingness to do something about it. Join what I call a climate truth organization. There are many out there. Citizens Climate Lobby has the approach of lobbying your representatives and your senators, maybe, but certainly your representatives in Congress to support climate-friendly legislation. And there's been they've had a fair amount of success. The approach is very non-confrontational. Young people, I would always suggest to them, join the Sunrise Movement. That's the youth climate movement. Here, pictured inside Nancy Pelosi's office. They're willing to do a bit of civil disobedience. I think it is way past the time where that is a legitimate response to inaction, government inaction on climate change. So Sunrise Movement, I have a lot of hope that they will play a big role in improving their own future. And the bottom line is that the future isn't set. It depends on choices we make, largely ones that influence how much carbon dioxide and other greenhouse gases end up in our atmosphere. And the difference is incredible. This is the world we're headed towards, which would be, it just would be incredibly difficult. This is a world that the Pentagon does not want to see happen. It's a world where there would be enormous conflict between human societies. And this is a different world that we could still have. The choice is up to us. And even though it sometimes feels like it, it is not too late to basically save the planet, end up with this as our future instead of the one on the right. Thank you very much for listening. And I'm, of course, happy to answer any questions to the best of my ability.
Thank you, David. We appreciate that. And again, this is Ian McNeil here joining, ready to field some of the questions that we've got from our members here. So first, I want to relay something to you, David, from Ben Hancock, who is referencing an article from this past Sunday's New York Times, which I believe is highlighting the climate report that was recently shared by the UN Commission prior to their climate conference that's upcoming in Egypt in a couple of weeks. In that report, they're referencing more a 2 to 3 Celsius degree range change as opposed to the 5 that you mentioned earlier. Do you have any thoughts on that?
Yeah, so if all the countries that signed the Paris Agreement and signed came up with their own what's called IDC, independently determined commitment. So each country saying, this is what I will do to try to help us reach that 2 degree target. if all of the countries adhere to their current declaration of what they will do, that would cause Earth to warm by between 3 and 3.5 degrees. So an optimistic view is that countries will do at least that. And so a 3-degree future, 3.5-degree future may be more likely than a 4.5-degree increase in temperature. But that really depends on what countries do. And in particular, China, India, and the United States, and Brazil, and the European Union. It's not at all clear that any of those, well, probably the EU, but the other four, it's not at all clear that they will meet their commitments. So if you ask me, which do I think is more likely, I think probably a 3.5 degree rise is the most likely. Because I think what we'll start to do is respond once it is very clear that climate change is causing massive difficulties. Even the California wildfires, the Midwest and Texas drought, the California drought, those didn't push us to act in this country. So I'm not sure what it would require, but I think we will act. We'll just act much later than we should. And as a consequence, I think we'll end up with 3.5 degree warming, which as was shown in some of those slides, it's not a good future. It's more like the 4.5 degree warming future than the 2 degree warming future.
Thank you. As a brief follow-up to that, you mentioned this massive event that would be required in some capacity for the world to respond accordingly. My inclination is that event would have to take place somewhere of significant destruction, correct? I mean, it's kind of silly for us to think in terms of disaster films, but if that takes place somewhere in a country where the United States doesn't have as much influence, would we be so inclined to act on that?
Well, I think it depends. It would, yeah, great point. It would depend, an interesting question. Depends on the strategic importance of that region to us, I suppose. That seems to be mostly what dictates our foreign policy. But I think the scenario that our national defense agencies are most concerned about, so Pentagon is most concerned about, is that due to climate change, the Himalayan glaciers, the glaciers on the Tibetan Plateau in the Hindu Kush region will, so think of Nepal glaciers, which currently supply almost 85% of Pakistan's irrigation water, actually their drinking water also, via the Indus River. So the Indus River is basically fed by glacial meltwater, but those glaciers are shrinking very rapidly. And it's possible that by mid-century or a little bit later in this century, the flow from the Tibetan Plateau will be small enough that India will need it all. And the Indus passes through northern India before it gets to Pakistan. If India says, look, I know we have agreements about water sharing, but we need to grow our crops and we need our people to be able to drink fresh water. So I'm sorry, we can't let any of that pass through and get to Pakistan. What option does Pakistan have? It cannot survive without it. They both have nuclear weapons. They are not on the greatest terms. So a big concern is a nuclear water war between Pakistan and India. I don't know if that would get the world to act on, to prevent further climate change. In the United States, I think the most likely cause of conflict within the United States is the region that we're in and the resource it has. We have all of this fresh water, which we are thinking right now of as ours. I mean, it's the states that border the Great Lakes that really have priority for using the Great Lakes, and of course Canada. But what if Phoenix says, we cannot continue to survive without fresh water, and so we want a pipeline built, but not to carry oil. We want a pipeline to carry water to us. Or the country decides that we need to grow crops in Kansas and Nebraska, and we just don't have, they are not able to irrigate. So we need Great Lakes water to do that. I don't know. I don't know what the outcome will be, but I'm almost certain that is a discussion that we will have in the next probably 20 years in this country. Is the Great Lakes water a regional resource, state resource, or is it a national resource?
Thank you. Oh, go ahead. Continue, please.
One last thing. One of the co-benefits of the kind of solar energy that basically uses mirrors to focus sunlight, basically all it's doing is creating heat that can be used to boil water. If you can make steam, you can make electricity, because the expansion of the steam turns a turbine, rotates magnets around a coil, and you get electricity. The only reason we burn coal is to get the heat to boil water, make steam. So the solar technologies that involve heating up something by focusing sunlight on it, that heat can also be used to convert salt water into fresh water. It can be a desalinization plant. So if you put it anywhere near a coast, then some of that heat, and you can generate way more heat than you need to make the electricity you need to make. Some of that heat can be used basically, boil water, but then recondense it, and the salts are left behind. You basically have fresh water. So that would be a co-benefit of expanding, not the photovoltaic solar, but the concentrating solar power type of solar.
Thank you. Just reading through the comments here, we had a number of people reference the Citizens Climate Lobby in reiteration of your point there, David. There is an active chapter, a very active chapter here in Holland. A number of our members are also members of that organization. And we actually have some upcoming courses with the HASS program for fall that are specifically related to electric vehicles, both the available options and the charging of electric vehicles in the future of those. So just a mention to all of those on the call now, if you haven't registered for those and are interested, those are available to you. Another question directly to you, David, is what do you think of efforts by people to influence those minds of Bill Gates and other wealthy members of the global community in the initiatives that they're promoting? Is that a viable opportunity for us to continue to pursue, or is it more demonstrative than anything?
I don't know. I think if any very wealthy person were convinced to use some of their wealth to help the world reduce greenhouse gas emissions, I think that would of course be great. But the amount of money that we're talking about, I think, is beyond any individual's level of wealth. So yeah, for sure, Bill Gates, if he could, $100 million is not going to make any difference. $100 billion would start to, but I think we've got to think in terms of large investments that probably only governments can make, tens of trillions of dollars. And it sounds like a huge amount, but the bottom line is we've gotten ourselves into a situation where we do not have a no-cost alternative. If we prevent climate change, it's going to cost us to make those green electricity power stations, for instance. If we don't make them, then we incur the cost of all the damage that isn't prevented, and is part of climate change. The economists, again and again, say from an economic point of view, the best strategy is prevent as much as you can. The cost of preventing is way less than the cost of dealing with it later on. But of course, the cost of preventing falls on our shoulders the costs if we don't prevent it falls on our children and grandchildren's shoulders. So I think it's an ethical issue that also argues we should do, that is, governments should invest a huge amount of money in preventing climate change. One thing I would say, sounds like a huge amount of money, but we've done it. We've come up with that amount of money in the last 20 years, at least once. No, on September 10th of 2001, we had no idea that we were going to be getting involved in a war in the Middle East. September 11th happened, and within a few months, we had decided as a country that whatever it cost, we were going to avenge or take out future risks or whatever the argument was. And the Iraq War, Afghanistan War, if you include health costs, lifelong health costs, the estimates are $30 to $50 trillion. And that's not a surprise. It was known that if we got into that war, it would cost us trillions and trillions. And we made that decision in a second. So we could make the decision, we're going to invest as much in preventing a horrible future for not just our country, for the world. And it would, we can find ways to pay for it. So I think, a war on climate change would be a really good investment.
You mentioned a couple of resources that you shared throughout your presentation, and we recently had a presentation about the growing debt crisis in the country. Is there something similar to that is available to us on a instantaneous basis to be able to check the rise or fall of temperatures globally or locally? You mentioned it for the bird species and migratory birds, but is there something that we can access daily, a chart or something virtually that we can access?
Yeah, great question. You always want to know what's happening in my backyard. I always do. And there are websites. I'm trying to think of which there. I think probably NOAA has a site where you wouldn't necessarily get a daily reading, but you can get a chart of what's been happening within your zip code. Maybe it's the Audubon Society that does that. I don't know the URLs off the top of my head, but I'd be glad to put them in a PDF and send it either to you, Ian, or to Bill. Yeah, places where you can. I think am I correct that what you're asking is really what's the most recent status for my area? There certainly are carbon dioxide level readings that are not necessarily daily, but monthly at the most, from Mauna Loa, from the Hawaiian CO2 monitoring station. But for trends in temperature, maybe, I can find at least two. I know I can find and send to you.
We appreciate that. Thank you. And another question here as we kind of get to the end of our conversation time. Coming back to your topic of protecting the Great Lakes from outside influences, what is the impact, or would there be an impact of the Great Lakes Compact to protect the water? Do any existing political agreements or contracts exist that would protect the waters here in the state?
I do not know. I
Okay.
I have a colleague who would be able to answer that off the top of her head, Denise Keel, who was a member of our climate change working group here, but is now the director of the Michigan Climate Action Council. I'm not sure, but she is a political scientist, and she
Okay.
Focuses on environmental law and especially climate law. I'd be happy to forward the question to her. She would almost certainly respond within a few days.
Well, speaking on HAS's behalf, we would definitely love to welcome her as well to share her perspective on the same issue. But I'll go to the final question that I've got here from another member online, David, is China is still building coal-fired power plants to meet its growing energy needs. And it's our understanding that China is actually the highest contributor to carbon emissions in the world. Did they sign the Paris Agreement? And if they did, how is the agreement enforced on a global scale like this?
Yeah, great question. So China surpassed the US as the greatest CO2 emitting country in 2005. But it's important to recognize that more of the CO2 that's in the atmosphere today was emitted by us than by China. So China became the annual leader in CO2 emissions. But because carbon dioxide stays in the atmosphere about a century, we have a higher cumulative carbon footprint than China. Nonetheless, China is the major player right now, and they scaled back on their expansion of coal-fired power plants, but you're right, they're still building them. China did make a fairly anemic IDC in my opinion, for the Paris Agreement. And the whole problem with the Paris Agreement, you hit it right on the head, is that there's no mechanism for enforcement. There's not even any mechanism for verification. So, then that's because we're not really yet, as a species, as a world, we're not really yet that concerned about climate change. So we're willing to let countries say, I'll do this, and then never check whether they do, and never have a way to make them meet their commitments. So I think that the only way you can bring pressure on countries to meet their independently determined commitment is the same way you would bring pressure on them to alter any policy, internal or international, that you did not like. So, sanctions, of various kinds. Michigan Climate Action Network, right? MCAN. So right now, I don't think there is any way to hold countries to their commitment. I don't think there's even any way to hold the United States to ours. If we meet our commitment, it's going to be because people like you and me insist that we do, that we pay attention, and that we communicate with our policymakers that we've made a promise and we can't break it. But that's not going to be the case in every country, and it might not even work in the US.
Thank you. I'll hand it off to Bill, who has one final question for you as the coordinator, and then I'll let Bill close the class.
Thank you. Mm-hmm.
Okay, can everybody see me and hear me? Carbon 14, I actually sent this to you. I'm just gonna read it. Do you agree, David, that the decrease in carbon 14% in the world's atmosphere is essentially a smoking gun that proved temperature rise is man-made?
Yes, at least that the increase in carbon dioxide in the atmosphere is coming from a biological source. And the reason, the argument is that plants, which is basically where our fossil fuels come from, but animals do this even more, they fractionate carbon. Carbon atom normally has 6 protons and 6 neutrons, atomic weight of 12, carbon 12. Occasionally, an atom has an extra neutron with C13, or 2 extras, which is C14. C13 is radioactive. I may be mixing them up. One is a radioactive isotope, one is a stable isotope, but they're both heavier than the normal carbon. So when plants do their metabolism, they preferentially respire off the lighter isotope. And so they become rich in the heavier isotope. When we burn them, we're now putting carbon dioxide into the atmosphere that is now rich in the heavier isotope. Burning doesn't distinguish between them, but respiration does. And so absolutely, Bill, you're absolutely correct that the change in the carbon isotope ratio in the atmosphere, which basically perfectly parallels warming on our planet, that is a smoking gun. Yeah, absolutely.
That's high school physics, and I was in high school more than 60 years ago. But the isotope of carbon-14 really is. I'm glad to hear you say it is the smoking gun that proves that temperature, CO2, increase in CO2 in the atmosphere is man-made.
Yep.
As a result of burning
Fossil fuel.
fossil fuels that have been underground and lost all of their carbon-14 due to
or not all of it, but the carbon-14's been concentrated in life forms because they respire off
yes,
the C12. So anything that was living, if its carbon is still around, it's going to be heavier than normal on average. Yeah, but you're absolutely right. It's a smoking gun. It means that we're doing something. We're burning something that is rich in C14, and that's, like you said, it's the plants that went into making coal. It's the plants and/or animals that went into making petroleum. Yeah, you're absolutely right.
Are there any other questions and so forth that people have put into chat that they'd like to open up their camera and their microphone and restate it? Or has everything been covered?
I think we've exhausted all of them, Bill, so we're good to close things up.
Okay. Well, David, thank you so much for
Thank you.
a very revealing presentation here, and presented in layman's terms to the point where most of us can understand everything you have presented.
Well,
so
great. Yeah, that's what I hoped to do.
Yeah, wonderful. Well, thank you again, and I will call this as being the final moments of this, unless somebody else has something else they'd like to say. Thank you all for joining us.
Thank you very much for having me and for listening. And I hope for sharing the information if you have the opportunity.
Well, this program is being recorded, so it can be viewed by anyone who wants to view it, and the general public can access these after this semester ends.
Yeah, great. Fantastic. Thank you, Bill.
Thank you once again.
Thank you, Ian.
Thank you, David. Take care.